Hello everybody, this is Dr. Sergey Sargasov, and today we will look into a special example of a geometric sequence and a series type problem. So let me first just ask us to divide some numbers. Let's begin with, let's say, number 1. Let's say the first term, or the 0th term even, is the number 1. Okay, and then maybe let's say I divide it by 2. Let's just keep dividing everything by 2. And so, okay, so let's do a little formula where we're going to do a sub n is the number of times we divide the number 1 by 2. In other words, 1 divided by 2, and then we're going to divide that by 2 and divide that by 2. So 1/2 times 1/2 times 1/2, and so on and so forth, n times, right? So maybe maybe subscript 1, 2, 3, all the way to n. And basically, what does that mean? That's 1/2 to the nth power, right? That's what it means. That's another way to write it. Okay, so that's our nth term. And when you do this, when you say a 0, a 1, this is a geometric sequence. Okay, sequence and geometric because it has a common ratio of 1/2. Keep on multiplying the terms by something, the same thing. So sequence is going to be a 0, a 1, right, a 2, a 3, okay, ellipsis. Now a series, the difference between a sequence and a series, and so basically this again, 1, 1/2, 1/4, 1/8, right, 1/16, so on and so forth. Okay, a series is basically a sequence of sums. Okay, so what does it mean, series? Let's see. Series would be, okay, let's call the sum 1 is just adding, the first, just having a 1. Let's start with the 1/2. So not really the 1, but 1/2. So that's equal to 1/2, okay? And then a series, let's say S2, it's the next term in a sequence of sums, would be A1 plus A2, and that's a 1/2 plus a 1/4. Let's not even calculate that. That's just, that's 3/4, but let's go on. With S3 being A1 plus A2 plus A3 equaling to 1/2 plus 1/4 plus 1/8. And then again, let's just go on and on and on to what is the formula if I did Sn. Sn would be the sum, right? That's the summation symbol, from I equals to 1 to n. So we're going to do n of those, a sub I, right? A1, A2, A3, all the way to an, you sum them up. And the question is, here's my question for you. What is S infinity, or a limit as n goes to, right, infinity of Sn? Where's this sum? Where's the sum? Where's the series, the sequence of these sums? Where is it going to in the long run? So equals to what? In other words, if I do 1/2, let's call it actually sum infinity is really equal to what? An infinite. It's an infinite sum. 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32, right, and so on and so forth, all the way to 1 over 2 to the basically infinity power, which is 0. But we're getting something getting bigger and bigger, some monotonically increasing sequence, right? And so what is it? Does it even have a limit, or does it go to infinity? Who knows, right? Let's see what happens. This is called the geometric series problem. So here goes. What I want to first show you is the insightful approach to solving this. Let's get a little, let's say, ruler or a shape like this. Watch. Here's a line, let's say. Okay. Let me show you what I would do. Here, I would say, hey, this is a meter long. So maybe this is like a meter, a ruler, right? This is 1 meter. And let's say, where is a half? About half is right here. Okay. And so you have, a ruler has, those measurements, right? It has tic-tacs for the, where everything is. So this is, let's say this is 50 centimeters, right? And this is, so that's the idea. That's 100 centimeters is 1 meter. Now, let's do 1/2 jump. Let's just say we're spot 0, 0. Okay. We're going to do a half jump, for example. Let's actually even, we're going to go from right to left. I've never really done this, but let's try it. Okay. So 1/2 is right here, and you jump 1/2. That's so we moved a half. Let's go backwards. So we start here, for example. All right, let's try that. So starting point. And then let's do this. Now, what's plus a fourth? A fourth is half of a half, right? So we're going to jump another, see that? Another half, but half of this interval now, okay? And then what is an eighth? It's jumping half of what's left. The fourth is left. That's an eighth right there, okay? Now what is a 16th? Yes, indeed, it is a half of an eighth, right? So we jump a 16th, we jump a 132nd, we jump a 164th, and guess what's going on here? We're approaching, so this is ending point, approximately. Approximate. This is exactly that starting point right there, and this is, approximate, because, it's not really exactly there ever, in a sense. So we are moving almost and then closer and closer to one unit, okay? And so that 1 unit seems like that's the answer to this problem, because think about it. We're always closer and closer, and how close are we? In fact, Sn, if you think about it, right? Even look at this. Let's look at the S1 is a half, right? And S2 is going to be 3/4, so you can try that. And look, what's happening is we're always like a half short of 1, a fourth short of 1, an eighth, so 7/8 short of 1. Now we're going to do a 16th short of 1, right? That's what's going on. And so guess what's going to happen with Sn? Sn is going to be 1/2 to the n short of 1. Okay, so that's a kind of a visual derivation of the formula. And of course, S infinity is then going to be basically the limit as n goes to infinity, okay? 1 minus a 1/2 to the n. And that's going to be 1 minus 0, 2 to the, 1 over something huge is basically very small. This goes to exactly 1 minus 0, which is 1, okay? That's really kind of almost like a proof. And in the real analysis class, you would have used the epsilon definition of, what existence of a limit really is. Okay, so that is what it is. Now let me show you the proof that we're used to more so in a more rigorous mathematical algebraic setting. So let's say, let's just write it again. How it looks. It's definitely, 1/2 plus 1/4 plus 1/8, right? Plus 1/16. Okay? And you know what? There are two ways to do it. I can multiply everything by 2, or I can multiply everything by 1/2 for the trick of this problem. Let's just do, common ratio is 1/2. Let's multiply everything by 1/2. So if I multiply the whole equation by 1/2, left and right sides, you get 1/2 of this, the sum that we're looking for. Let's say we didn't know this. It's equal to, well, what's a half times a half? That's a fourth. What's a fourth times a half? That's an eighth, right? So every term goes to, plus a what? What is this? It goes to half of it itself. So 1/16, and then plus, what is that? 1/32, right? Now, and so on and so forth, right? So what happens when I subtract? What if I subtract this equation from that equation? The top one minus the bottom one. What's something, this S infinity, minus 1/2 S infinity? Well, something minus half of itself is just half of itself. 1/2 sum that we're talking about is equal to, now look, here's a half, right? And then what is a fourth minus a fourth? Yeah, that's 0, right? Okay. What is an eighth minus an eighth? 0. What is this and that subtracted? 0. So this is plus a 0, plus a 0, plus a 0, plus, yeah, you better you've guessed it. This is, there's going to be all zeros all over the place to infinity, but it's always, there's some plus 0. This is equal to what? 1/2. Okay, so 1/2 sum infinity is equal to 1/2. Guess what? Sum infinity, or sum, the sum we're looking for, is equal to 1. Ta-da! So hopefully you enjoyed this short lesson, and take a look at that, take note of it, and you can do any geometric sequence series type problem in this way, especially this one. Not as insightful as the one at top above. My favorite is this above, just understanding what in the world is going on. Okay, but yeah, you can also always do it this way. All right. Thank you for watching. Have an amazing day.